All right, hello everyone. Today was day 22 of Advent of Code, and today we've been playing 3D Tetris again. So we're considering bricks of sand today, and they're dropping just like in Tetris, and as soon as any position of this brick hits another brick, they stop dropping. And our input is a snapshot of the bricks while they're falling, so we have some coordinates of the bricks given, and that will give us something like this. So we have a ground at 0, and then we have some bricks which different positions, and some of them, like this G brick, are not landed yet, so they are in the air. And what we're supposed to figure out for the first part is want to drop the bricks, so move them downwards until they hit another brick. And then we're supposed to figure out which bricks are safe to disintegrate after dropping them. So safe to disintegrate means if you remove a particular brick, then no other brick is supposed to fall. Okay, so how can we do that? So again, today we will have positions, which will be a tuple of x, y, and z coordinate this time. And then in order to capture the brick and its current position, we'll have this class, and its data class, and we keep track of the x, y, and z coordinate, and as well as the, I choose to represent them also using the height, the width, and the depth. And one thing we set is this equal to false, which just means when we hash bricks, the hash function will depend on the object ID, and we can hash them. So that will be useful to be able to use bricks as a key in a dictionary. And then we define two properties for convenience. So for one of them is all the positions that a brick occupies. So there we just go through each coordinate for the corresponding range, and then we generate all the tuples of x, y, and z coordinate. Second is a similar thing, just with the base positions, that we do the same thing, but just for the x and the y coordinate. Okay, so that's how we want to represent bricks. So we need to parse them from our lines. So today we can parse each line separately. And then in order to parse a line such as this, it's also fairly straightforward. We just get the starting positions and the ending position by splitting the line by this symbol. And then we use that to parse the start, the end. That allows us to calculate the size. And then we initialize a brick based on the starting position and the size. Okay, and then our main function will be to drop the bricks. So it will get a list of bricks as an input. And then what will be very useful is to have this dictionary, which tells us for any x and y coordinate, what is the smallest empty set position at this coordinate that's an empty position. And so at the beginning, all the smallest empty set will be 1, because at 0 there's the ground, and we use a default tick to represent that at any position the smallest empty set at the beginning is 1. Then what we want to evaluate is not just the new positions, but also this rests on dictionary, which for each brick tells us the set of brick this brick rests on. And for that, it will also be useful to keep these positions to brick dictionary around, which just maps each position to the brick at that position. Okay, so then in order to drop them, what we will consider is all the bricks. However, one trick will be to sort them. So we sort them by the z coordinate. So we drop the lowest bricks first, which then I guess that's how the problem works. And then we just go through these bricks sorted like this, and each brick we drop as far as possible. So for that, we evaluate this new set position, and we go through all the positions in the space positions of the brick, x, y coordinates. And then we just check what's the smallest empty set coordinate at this particular position. And then the new set coordinate for the brick will just be the maximum of all of those values. So what we do, we set the set coordinate of the current brick to this new set. And then first we want to update the smallest empty set dictionary. So we just go through all the base positions of the brick again and update the dictionary at this particular value to the lower position, to the starting position of the brick plus the height of the brick. Similarly, we want to update this position to brick dictionary, where you just go through all the brick positions and update the dictionary. And finally, we want to update this rests on dictionary. So there we just again go through the base positions, and then the position below will be given by this triple. And we check if this position below is in the dictionary, we get the brick, otherwise we get none. And then we check if the brick below exists. If it's not none, then we add the brick one step below the current brick, we add that to the set of bricks the current brick rests on. All right, so that's our main function. With that, we can solve the problem. So we just parse the line to get the bricks. Then we drop the bricks to update their set coordinates and get this rests on dictionary. Then it will be useful to have this supports dictionary, which is essentially the inverse of this rests on dictionary, where we map each brick to a list of brick it supports. So we just go through the rests on dictionary to get each brick and each bricks that are supporting this brick. And then for each brick that is supporting this brick, we just save that in the dictionary. Okay, and then in order to solve it, we just go through all the bricks and we check if the brick is safe to disintegrate. If this is true, we increase the count, and then our solution will just be the count of all these bricks that are safe to disintegrate. Finally, this safe to disintegrate function will take a current brick, and then first it considers all the bricks that support, all the bricks which that brick supports. So if those bricks only rely on the current brick, then they would fall if we remove the current brick. So that's what we're checking here. We check the number of bricks the supported bricks rests on. If the number is 1, that means it's only resting on the current brick, and if we remove it, the supported brick will fall. So in this case, no, it's not safe to disintegrate. And otherwise, if there's either no supported bricks or all the supported bricks are supported by at least another brick, then we return true. We can't disintegrate the current brick. All right, that's it for part 1. Of course, you should run it on the test input, and that looks good. It also gives us the correct solution if we run it in real input. So yeah, part 2, there we want to actually count the number of falling bricks. So if we remove a particular brick, then some bricks might fall. So every brick that's supported only by this removed brick will fall, and that will cause more bricks to fall, and so on. So for each brick, we want to evaluate how many bricks are falling, and then the solution will just be the sum of the number of bricks are falling for each brick. So if we remove a particular brick, how does this function work? How can we evaluate the number of bricks that are falling? So first, we want to keep track of this set of bricks that will be gone eventually. So that will include all the fallen bricks as well as this removed brick. So at the beginning, it starts with just the one brick we removed. And then we go through all the bricks. And again, we will sort them by the C coordinate. That will be useful because whether a brick falls or not will only depend on bricks that start below it. So first we check if this current brick has a C coordinate of 1, which means it lies on the ground, which means it definitely will not fall. So we continue. Otherwise, we check all the bricks this current brick rests on. And if this is a subset of the gun bricks, set of gun bricks, so this means all the bricks the current brick rests on are gone already, then the current brick will fall. So essentially, and then since it's falling, we add it to the set of gun bricks. Okay, so going through this will tell us all the bricks which will be gone after by removing this brick, and then the number of bricks that have fallen will be all these bricks which are gone in the end, but we have to subtract 1 because this also the brick we removed ourselves is also in this set. All right, with that we can solve part 2. So again, like in part 1, we need to parse the lines to get our list of bricks. Then we want to drop the bricks to update their set coordinates and get this dictionary which brick rests on which other bricks. Then we just go through all the bricks, count the falling bricks if we remove this brick, and the solution will just be the sum of all of this for all the bricks. Of course, we should run it on the test input. That looks good. So we can also run it on real input, and it also turns out it gives us the right solution. Okay, that's it for day 22. I hope you enjoyed today's puzzle. Best of the luck in the few remaining days, and I hope to see you around.